Hey guys, today again, as I said, we're going to be looking at matrices. Okay, so the concept of matrices. Remember, the first thing we need to know about matrices is what is called the order of a matrix. The order of a matrix tells you how many rows and how many columns it has. So, for example, this first one here is a 3 by 3 because it has 3 rows and it has 3 columns. Also, in this section, notice that they're showing this is our revision because you did this last year. You have addition of matrices. And remember, there's a rule to addition. In addition of matrices, if you want to add two matrices, they must have the same order. So notice here, the first one, it says it has a 3 by 3 added to a 3 by 3. So the 1 is added to the 9, the 2 is added to the 8, the 3 is added to the 7, the 4 is added to the 6, the 5 is added to the 5, the 6 is added to the 4, the 3 is added to the 7, the 8 is added to the 2, and the 9 is added to the 1, giving you all tens there. Also in here, notice that they have the combination of scalar multiplication and subtraction. Notice the topic there on scalar multiplication. It shows that whenever you scalar multiply, the number outside is multiplied to every element inside the matrix. All right? Then it talks a little about matrix multiplication, where it says that the multiplication of a matrix is associated, which means that if I have A times B times C, I can multiply B and C first, then A, or I can multiply A and B first, then C. So all of that here is what we've looked at before. Then it has, of course, matrix multiplication, right? Right here where you multiply row by columns. So notice how they have it there. First row times first column gives you the first entry there, and that means that here until the last row, last column goes there. So remember that. So it has an example of how to use matrix multiplication there. We may look at an example as we go along. Then here we have the equal, an example of how we use the matrix multiplication. So notice how they have it. It says example 1, negative 1, 3, 4, h times k5 will give me negative k plus 15, because you say negative 1 times k, that's negative k, plus 3 times 5, that's the 15, so negative k plus 15. And then in the other one, it says 4 times k is 4k, plus h times 5 is 5h. And then they say that negative k plus 15 and 4k plus 5h is equal to the matrix 0, 0. And then they solve. So negative k plus 15 equals 0. So k is equal to 15. And then it says 4k plus 5h equals 0. And we know that k is 15. So 4 times k is going to be 60. So we say 5k equals negative 60. So h is negative 12. So you're looking at both matrix multiplication and something called equal matrices. Again, something that we have done before. All right.